Autogenous technology is one of the key techniques in all segments of industrial and handicraft production and processing. The term autogenous technology refers to production techniques where heat is produced by means of fuel gas and oxygen for metalworking. Amongst the techniques that are most often used in practice are gas welding, flame straightening, flame cutting, flame gouging, flame blasting, flame brazing, flame heating and flame spraying. As the preferred fuel gas, acetylene is used here because it has good combustion properties. But also propane, natural gas or gas mixtures are applied depending on the requirements of the flame. In gas welding, metals of the same type are melted in the welding zone and then are directly connected by a specially alloyed welding rod or wire. Gas welding is mainly used for connecting sheets and tubes of steel, but also cast iron and non-ferrous metals can be welded autogenously. Accordingly, the technique is mainly applied in pipe and plant engineering and for assembly on site. Flame straightening means a rapid and localized heating of components with the aim to give the component a desired shape or to eliminate form deviations as they occur in every welding production process. The rapid and localized heating causes an expansion of the workpiece, which is, however, hindered by the surrounding cold areas and results in a permanent compression. When cooling down, in the compressed zone, forces arise that lead to the desired change of form. This technique can be implemented with a variety of materials, for example, steel and aluminium, and is mainly used in steel construction, shipbuilding, container construction, mechanical engineering, and the automotive industry. Flame cutting is a separation process mainly for steel workpieces. It is based on the property of the material to ignite and combust in a jet of pure oxygen at temperatures below the melting point without melting. First, the workpiece to be cut is preheated by a heating flame to ignition temperature of the material, almost white heat. Then a jet of oxygen is blown onto the heated area, which initiates, whether by hand or machine, the combustion of the material. In this combustion process, thermal energy is produced that heats the interface to the depth of the material continuously to ignition temperature, and like this, maintains the combustion process through the entire thickness of the material. Likewise, the oxygen jet works its way through from the workpiece surface to the bottom. The incineration slag is discharged by the pressure of the oxygen on the bottom side of the workpiece. Through the burners slow moving in the desired direction, a thin parting line is achieved. Flame cutting is applied especially in shipbuilding, mechanical engineering, and steel construction. Flame gouging is used to remove certain material parts from metals. Afterwards, the finished surface is clean and smooth. The technique is comparable to flame cutting. An oxy-fuel flame melts the material and an additional oxygen jet blows away the molten material. The position of the burners, however, varies. In flame cutting, the oxygen jet is directed straight onto the workpiece and towards the bottom side of the workpiece to achieve a cut. In flame gouging, the oxygen jet is led nearly parallel to the workpiece surface to achieve a groove or gap or to remove a surface layer. Main application areas of the flame gouging torch are shipbuilding as well as steel and container construction. Flame blasting plays a significant role in concrete and steel refurbishment and in civil engineering. Buildings, roadways, hall floors or steel constructions must increasingly be repaired and maintained for reasons of value maintenance and static safety. Flame blasting is used when concrete, natural stone or steel surfaces are to be freed from rubber abrasion, petrol, grease, de-icing salt or rust, in order to improve, for example, the adhesion of a protective covering. The heat shock caused by the autogenous flame will quickly result in flaking of the upper layer. In flame brazing, metallic materials are connected to each other by solder as a molten filler metal. Unlike welding, in brazing processes, not the workpieces themselves, but only the solder is melted. This requires a solder with a lower melting point than the workpieces. In brazing, also largely dissimilar metals of different geometries can be connected to each other. The application area of flame brazing ranges from the installation trade and automotive industry to the mechanical and aerospace engineering sector. Flame heating means local heating preparatory to hot forming, for instance for bending pipes, necking distributors, forming container bottoms, or for pre- and post-heating, so-called soaking, in welding and flame cutting. The technique is preferably applied in the automotive industry, but also in steel and container construction. Flame spraying is used for surface coating of metallic and non-metallic materials. The spray material, wire or powder, is melted by the oxyacetylene flame and sprayed with compressed air or another gas onto the pre-treated workpiece surface. The high temperature of the flame also allows to spray refractory materials such as molybdenum. Flame-sprayed coatings have proven themselves in all areas of technology, for example as wear protection coating, for quenching and tempering machine elements, or for applying corrosion protection coatings of zinc, aluminium, copper, or chromium-nickel steel. Autogenous technology impresses again and again, but not only by its wide variety of applications. The techniques also stand for comparatively low investment costs, a minimum amount of equipment, and the comfortable energy supply in form of fuel gas and oxygen. They guarantee universal applicability and high efficiency of autogenous technology at every location.